Okay, so we're going to talk about another typical problem that's in algebra. This is kind of like a typical polynomial frame problem. This usually is in Algebra 1. It does carry over in Algebra 2 in some complex ways, but the idea begins in Algebra 1, and there's a lot of complexities to it. So let's read it. So first off, Olivia has a painting below that she made that has the following dimensions. She has an L, which is the length, which will be x plus 6, and then so we'll put that length right here, x plus 6. It's always good to add your dimensions to the picture. That's why I waited to do it, just as a general practice. And then we have the width, which is 2x minus 3. So on this side we have this 2x minus 3. So what is the area of her painting? Now the question isn't finished, but so we can figure that out. But let's first continue the question, and then it says she wants to put a frame around this picture that is 3 inches wide. And so what is the area of the frame without the included art? So we need to know what the area of the painting is, and then we need to put a frame around it, and then we need to figure out what the area of the frame is without the area of the painting. So well, that sounds like we're going to do a couple of things here. So let's find the area of the art. This is how good I am at art right here. Art, this is my painting. So I'm going to just take this, and we're going to use a method that we can utilize any single time. Now there's lots of methods for solving the product of two binomials, but why am I multiplying them? Because when I'm looking at a shape, right, and this is a square or a rectangle, the process for finding the area of any rectangle is just the length times width gives me the area. So if I have a length and a width, I just multiply them together. That will tell me the area. So if you haven't learned the area model technique, I would recommend it as just a way to avoid potential errors if you haven't learned it. But here you can pick it up, and the area model is actually literally building an area and just putting the information along the top, and then this information along the side, and then I just fill in the boxes. So 2x times x, 2x squared, 2x times 6, 12x, negative 3 times x, negative 3x, negative 3 times 6, negative 18. And then what I can notice is that these two terms, and oftentimes if we are going to have like terms when we multiply, it's the diagonals. And the reason that works out is these have the same exponent. If these had different exponents, we would have a different, we might not be able to combine like terms, but that's for practice. So let's just write out what we have in this right here. 12 minus 3 is 9. Minus 18. So this right here is the area of the painting. So we got to get a little more difficult, because we need to add, what do we need to add? We need to add some unit, 3 inches of a frame. So I'm going to just kind of go around it and just put a makeshift frame around this. It doesn't have to be perfect, but imagine there's a frame around it, and it's not going to be perfect. Again, this is about sketching the idea so that we can build an understanding of what is happening. And if I overlap some of my stuff, it's because I just can't erase that fast, not like a computer screen that some people use, but this is more real world, which you should be doing this stuff on paper to really build depth. So it's okay if these things aren't the correct, because it's a sketch, and we're going to take a look. We have 3 inches wide, so that means that from this distance right here, that is like 3 inches, and on this side, that is 3 inches. So what we can now do is kind of think about when we look at this stuff, and we kind of just going to get a couple of different colors. When we look at it, so if I kind of think of like this distance here, that is this distance here, which is 3. Well, over here, this is 3, so this distance here is also 3. And then this distance all the way from here to here is x plus 6. So if I kind of think about it, I have this 3 plus x plus 6 plus 3. So the total distance is 3 plus x plus 6 plus 3, which is, if I kind of draw like a thing around it, that would give me, and I'm going to put that dimension down at the bottom, x plus 12, because I can just add everything up. And we can do the same thing along the side. We can kind of think about like this distance here is also 3, and this distance here is also 3. So if I'm looking at, again, right, I have this distance here, so from here to here is 3, and from here to here is 3. That means from this point right here to this point right here, this distance, oops, sorry, I should trace a little bit better, is, what do we know that is? Well, that is 2x minus 3. So this distance here is 2x minus 3 from that point to that point. So if I just kind of add everything up, 3 minus 3 plus 3 is 3 plus 2x. So this whole length right here is 2x plus 3, right? Because 3 minus 3 plus 3 is 3. So now I have my new dimensions for the big frame with the art. So this is the frame plus the art. So the frame plus the art has these dimensions. And so I can find the area of the frame and the art together just by multiplying these two. And I'm going to use the area model just to stay kind of this consistent in the process, right? So if I look at the area model, and again, it's just a quick sketch of looks like a window pane, or some of you may have called it a Punnett square from science, but 2x squared, 3x, 12 times 2 is 24x, 12 times 3 is 36, and again, the diagonal is the same. So we end up with 2x squared, 24 plus 3 is 27x, and then plus 36. And that is the area of the frame and the art, So like that's the total area. But what do we have here? We have the area of just the art. So if I take, and I'm going to sketch this, so if I take the area of both the frame and the art, so I'll take this box, and I subtract just the art, right? I take this art out of it. What am I left with? I'm left with the frame. And that's why I said this is kind of like a typical polynomial frame problem that you will come across. Well, that means that I take the area right here, frame and art, of 2x squared plus 27x plus 36, and I subtract the area of, what did I get for the area of, that's right here, this 2x squared plus 9x minus 18, right? And that is the area. So, let's say I just have to do some, some remembering of how to handle the polynomial subtraction. And so this is just kind of a general rule, right? If I have a subtraction sign in front of parentheses, well, we distribute. And so I'm going to change all the signs inside the group. So I'm just going to change all the signs first. So this one's positive, so it becomes negative. This one's positive, so it becomes negative. This one's negative, so it becomes positive, right? And so the numbers just fall into place. I don't have to actually change any of those. I just change the signs. But now that I've distributed that, I can basically say, all right, well, I can add the groups, right? So now I have this up front here. And now I have a situation where, because I have a plus sign between groups, the signs aren't going to change anything, but I can basically drop the parentheses and group the like terms. So I have a 2x squared and a minus 2x squared, so I'll group those two, right? And I'll just keep them grouped. So plus sign between them is just for the grouping purposes. I have 27x right here, and then minus 9x. And then I have plus 36 plus 18, right? 36 plus 18. And now these two, there's a zero pair, so they just cancel out. They equal 0. These two, 27 minus 9 is 18x. And over here, 36 plus 18, well, that's 46, 54. And so the area, right, the area of the frame is the whole area minus the picture gives me what's left in the frame. And so here would be the area of the frame, right? That's my area of the frame. And of course, any question could give you and say, all right, well, I can give you some value for what that area is and say, okay, well, the area of the frame might be, I don't know, 200 or whatever. Well, you just plug 200 in here and you can find x. All right, so this is a typical polynomial problem that you come across in algebra. It is a little tricky, but it's at the high end, and it is also one that demonstrates about about half of what the unit in this unit for Algebra 1 would require you to understand, but it's also quite complex. So hopefully that helps.